Hello, welcome again if you've seen any of my videos here. In this video, we'll have a look at two distances from two of the highest mountains in the world. Mount Everest in Asia, the world's highest mountain, and Mauna Kea in the Pacific Ocean, number one there. And we'll look at the distance from first Mount Everest to the Arctic Circle and the North Pole. And here there is a unit of measurement ratio ordering those two distances. That's important. And when we look at Mauna Kea, right here, we have a distance exactly to the South Pole. That relates perfectly to the full pole-to-pole circumference of Earth, again with a very precise unit of measurement ratio. And when I say unit of measurement ratio, I mean the ratios between these very units that we today use to measure distance. And in the first case here, of Mount Everest here to the Arctic Circle and the North Pole, the ratio ordering those two is that between the kilometer and the mile, exactly the kilometer-mile ratio. And in the second case, Mauna Kea to the South Pole is as 1 foot, while the full pole-to-pole circumference is as 1 meter. So the meter-foot ratio, precisely, or very, very near exactly, in both of these examples. But let's start measuring then from Mount Everest to the Arctic Circle and the North Pole so that you see the evidence for yourself. So let's go to Mount Everest and measure first in kilometers then to the Arctic Circle. And the Arctic Circle is 66 degrees 34 minutes north, a little shy of that. And that's where we'll go now first. So let me just move north here to the Arctic Circle and locate it as best I can. And right around here in Siberia, we find it where, let's see, 66 degrees 33.57 or thereabouts. At least we have a distance. If you see here in the window here, 4,291.6 or thereabouts in kilometers. Very near exactly there. And now we're going to move instead to the North Pole and see the same numbers come up in miles that we now had in kilometers. Just extend this line to the North Pole from the peak of Mount Everest. And the North Pole is where I put this little pin here. And I'll just zoom in a little bit more in a second. Moves a little bit slowly, but just give me a second here. So just around here we have the North Pole. And if I shift to miles now, we'll see the same numbers come up in miles. Here we have just around 4,291.8 miles. Almost exactly the same we had in kilometers, if you look in the window here. So that means then that Mount Everest relates to these two very important non-physical features on the surface of Earth with 1 kilometer and 1 mile, the highest mountain in the world. And of course these two, the North Pole and the Arctic Circle, is defined by Earth's tilt on its axis in its yearly movement around the sun, and it defines the seasons. So the kilometer-mile ratio there. Now let's look at Mauna Kea and its distance to the South Pole in feet this time. And with there seeing feet, the same numbers come up as we see in meters or kilometers in the full pole-to-pole circumference. So let's just measure and move ourselves down to the South Pole first. I'll be there in a little while. Right down here we have the South Pole. In a second, it moves a little bit slowly, but we'll soon be there. And here we have distance in feet, if you watch the line here, that is just around, I think I'll have to zoom in a little bit more, sorry. sort of like this. The distance in feet, that is just around 40008 and a little bit more in feet. And the full pole to pole circumference of Earth is 40,008 kilometers, or in meters. And that makes it such that, as I said, Mauna Kea to the South Pole is as 1 foot, while the full pole to pole circumference is as 1 meter. That was another example of the unit of measurement ratios ordering the most important features on the surface of Earth. In this case, mountains, the poles, and Arctic Circle also. So I think that was it for this video, and if you looked for this long, thanks for watching.